Hello, good evening everyone, good evening and welcome to India's first animated live tuition. Hello everyone. Yes, quickly turn on the cameras, quick. Let me quick. Yeah, someone is waving their hands. Hello. Yes, quickly turn it on. Good afternoon, good afternoon. Yes. I broke my hand. Who broke her hand?
Yes, Neha does.
Neha, can you please unmute her?
No. Wait.
Yeah.
Yes, Neha does.
Neha, what happened?
Yeah.
Did anyone broke your hand?
No, I broke it myself.
Yourself?
Right
For what?
hand. Yeah.
For what? You were just bored, so thought like, let's break my hand. Was it like
No,
that?
of course not. Ma'am.
It's not like that, ma. Then what happened?
I was cycling and a cat came in front of me.
Cat came?
Yeah.
Alright, so next time be careful, okay?
Yeah.
Can I see
and
your
I
hand?
can't write anything now.
Can I see your
Because
hand?
it's my right hand.
Oh,
Okay.
yeah, I feel so sorry for you. Take care, okay? Yeah, alright. So, rest of you students, ready for the class? I can see so many cameras there. I have told you before, I won't allow that. Quickly turn it on. I'll give you 1 minute. 1 minute is more than enough, right? Yes, quickly turn it on. Should we call out the names? Are you waiting for that? To call out your names? No, ma'am. We'll do that. Yes, good children, good. So, let's begin the session, shall we? Give me a thumbs up before that. Give me a thumbs up so that we can move towards our portion. Shall we do it? Yes, everyone is giving me the beautiful thumbs ups. Very good. So tell me, which chapter are we going to do? Which chapter are we discussing right now? Tell me in the comment box. Which chapter are we discussing over here? In the last session, what was that chapter name? Definitely, yes, it is nothing but
surroundings.
matter in our surroundings. Matter in our surroundings. So, have you studied everything that we have taught in the last class? Is that a yes or no? Yes, very good. Yes, very good. So, here we go. First of all, let's unmute someone, ma'am, first.
Okay, let's ask Daniel Joshua.
Daniel is raising hand.
Yes.
Yes, Daniel.
No, teacher, I want to say that we before studied matter in our surroundings.
Before studying matter now, this is our first chapter, right? Matter in our surroundings. This is our first chapter.
Yes, teacher.
Alright, Daniel. Tell me what was the things that we were discussing in the previous session.
Teacher, we were discussing that matter is the mass and that occupies space. Like matter is called matter which has mass and occupies space.
Definitely yes. Then, what else we discussed?
Physical nature and
Physical nature of particles of matter. We discussed that, right? Then, what else?
then teacher we did an activity that
we have done so many activities. Very good.
so the last time.
Glass and sugar particles, right?
Yes, teacher, but the animation you show that one powder, like one purple powder, I forgot the name of it.
You forgot the
You
name?
that which turns purple, which turns
Potassium
purple.
permanganate.
Yes, teacher.
Can you repeat that? What was the powder?
Potassium. What?
Permanganate. Permanganate.
Permanganate.
Yes, potassium permanganate. Very good, Daniel. I know you remember everything. Very good, very good. So, we have the new students, right, ma'am?
Yes.
Yes, can you just raise your hand? Who are the new students in our class? You can just raise your hand, okay? We have so many. Very good, very good. watching me for the first time, isn't it? Oh,
Yes, I
very
think
good.
so.
We have so many. Welcome to our family 90 plus and to the chemistry class. So, can you please unmute one, ma'am?
Let's unmute Muhammad Aris.
Aris.
Yes, ma'am.
Hello, Aris. Is this your first class?
Yeah, ma'am.
Yes, very good. Where are you from?
Ma'am, I'm from India, Tamil Nadu.
Tamil Nadu. Currently staying in?
What, ma'am?
Currently where you're staying?
Now I'm staying in Sharjah.
Sharjah. Very good, very good. Welcome to our class. So daily, day by day, let's get to know each other, okay? I'm not going to call
Okay.
out everyone right now because we have so many portions to complete. I will interact with you by day, okay? We can get each other by day after day. So here, the chapter that we are discussing is matter in our surroundings. That is your first chapter, okay? Matter in our surroundings. We had discussed what exactly is matter. Am I right? Do you remember this? Matter is anything that has mass and occupied space is called as a matter. I'm not going to repeat this over and over. You may get bored. So I'm skipping this part again. We have already discussed this so many times. Then the thing that we have discussed in the previous class was physical nature of matter, which was an important topic. Do you remember this? Do you remember this? Ma'am, is this chemistry?
Yes.
Definitely it is chemistry. Yes, that might be a new student, I guess. Okay, this is the chemistry class and the chapter that we are discussing right now is matter in our surroundings, which is the first chapter. Ma'am, can you please unmute someone?
Okay, let's unmute Fatima Faiza.
Fatima. Hello Fatima, how are you doing?
I'm good.
Doing good. So can you tell me the physical nature of matter?
From last class, I was not there. I'm a new student.
Oh, you are a new student. I'm really sorry for that. I didn't knew that. So that's okay. Since this is your first class, I'll give you an excuse. Okay.
Okay, let's ask Sanjit.
Sanjit. Yes, Sanjit. Sanjit is so much ready to answer it, I guess.
Yeah.
Raising his hand. Yes, Sanjit.
Yes, so every matter is made up of certain particles is called atoms and molecules.
Definitely, yes. What about the nature of these atoms and molecules?
There's space something of 1 into 10 by 18.
Alright, they are very tiny in nature, right? Yes, they are very small or very tiny in nature. So we had discussed, very good Sanjay. So the physical nature of matter. Every matter is made up of certain kind of particles and I can call that certain particles as atoms or molecules. And as I have told before, these particles are very, very tiny in nature. We cannot see them with our naked eyes. So we have proved this by using an experiment. Which was that experiment? By doing one experiment, we have proved that the matter will be consisting of tiny, tiny millions and millions of particles. Now you have to tell me which was that experiment. Yes.
Okay,
Tell me in the comment box, quick.
Yeah, so many of them is commenting.
Commenting,
And
yes.
what sugar in water, salt.
Sugar in water, salt in water, and yes,
let's
we
unmute
have
someone.
conducted a live experiment and also the animation was there. Yes, ma'am. Unmute someone.
Okay, let's unmute Rupesh.
Rupesh. Yes, Rupesh. Which was that experiment? Rupesh, can you please unmute?
Rupesh.
Rupesh has some troubles, I guess.
That's
That's okay. We have the answers in the comment box, which is nothing but KMNO4 crystals in waters. So can we have the animation? We saw an experiment by an animation, right through an animation. So animation was nothing but our KMNO4 was dissolving in water. Let's do it again. Okay, let's recollect those points. And new students, listen carefully, okay? So here we have, what do we have right here? We have the beakers and we have the distilled water and the KMnO4, which is nothing but potassium permanganate. Potassium permanganate. So what are we going to do right now? Simply. So let's take this distilled water in each test tube. Okay, in each test tube we are going to take the distilled water and let's put some grains, a small amount of KMnO4 in the first beaker and let's mix it well. So did you saw the color formed? Yes, definitely ma'am. We don't have any color blindness. We can see that color. Yes, we have the color in the first beaker. And let's take out 10 ml from that. Before that we have to add 90 ml of water inside this beaker, okay, to make it 100. So let's take 10 ml from that, let's pour it over here. Again you can see the color, Again let's take the distilled water in this third beaker, 90 ml. To make it 100, let's take 10 ml of this solution and pour it to this. Again we can see the color. Again let's repeat it by using the distilled water and 10 ml of the solution. Again the color persists. You can see that, right? Again we can see the color. Again let's do it. 90 ml of distilled water and 10 ml of the solution from this beaker. So again we can see the color. Okay, color is getting faded, but still we can see the colors. So I have explained this in the last class. That's why I'm going a bit faster because we have to cover the rest of the portions, right? So what did you understand from this specific experiment? What did you understand? Ma'am, it looks like purple. Definitely. Yes, it looks like purple. Now let's unmute someone, ma'am.
Okay, let's unmute Vinayak.
Vinayak, what was the core point from this experiment?
It means that whenever you put the potassium permanganate, it dissolves and changes its color.
So what you indicated by this? What is indicated by doing this experiment?
Uh,
The matter is consisting of millions of particles. Am I right?
yes, ma'am.
Yes, from this experiment, it is clear that the matter of this even single grain of the KMnO4 can color this much solution. Even a single grain of KMnO4 can color this much solution. That means that single KMnO4 crystal will be having millions and millions of particles inside that, and that particles are very tiny in nature. We cannot see them. So if we mix those particles here, they will dissociate into smaller particles. They dissolve into smaller particles. Hence, they will color in each of the beakers. Okay, we have discussed that detailing the previous session, so that I am moving forward. So what is indicated by this? The matter will be consisting of millions and millions of tiny particles. That is the physical nature of the matter. Now let's leave it and go back to the next one. So you can remove it. Let's go back. Here, the characteristics of particles of matter. In the previous session, we discussed two. Am I right? We discussed two characteristics of particles. What was that? What was the two characteristic? Let's unmute someone, ma'am.
Okay, let's unmute Abhinav K. Arun.
Abhinav, what was those two characteristics of particles that we discussed in the previous session?
They take up space and they also have mass.
Yes, okay. The particles will be having space in between them. The particles of matter have space in between them. In order to prove that, we took one glass of water and added some sugar in it. The water level was not increasing. Where does this sugar go? Sugar occupied the space in between the water molecules. Let's look into the animation. So the animation of what? Yes. And I have clearly explained that the water particles will be having space in between them. Here we have the water glass. You can see that, right? And let's zoom it. Okay, let's zoom this water particles. Yes, sir. And here we go. These are the water particles. They are moving around, and as you can see, they have space in between. So the particles will be having space in between, as you can see over here. So what is the first characteristic of particles of matter? The particles will be having space in between them. Now, the thing that you have to remember is, I can call this space as intermolecular force. I'm sorry, space. Intermolecular space. Okay. So, pause there. Now, here. Pause there. Can I write, sir? Yes. So, here we go. This particle space. It's not over there. I cannot write it, right? Okay, fine, I'll explain. So here we have the space, right? And I can call this specific space as intermolecular space. Okay, was that clear? Intermolecular space. Intermolecular space. Quickly write it down. Quickly write it down. What is the space in between two particles? The space between two particles or two molecules is known as intermolecular space. Quickly write it down. What is intermolecular space? The space between two particles is known as interparticle space. Okay, I have told you the particles will be having space in between them. Sorry, they have space in between them. What can I call that space? Ma'am, can you please unmute for me?
Okay, let's unmute Grisha Kotian.
Grisha?
Kotian?
Yes.
Yes,
Yes, Grisha. What is the space called as?
intermolecular space.
Definitely. Very good. Intermolecular space. So the thing that you have to remember is the particles will be having intermolecular space between them. Was the idea clear for you? Was the concept clear for you? Give me thumbs up. Give me thumbs up. Quick. Give me thumbs up. If this is clear so far, give me a thumbs up, or you can raise your hand to ask questions.
Yes.
Everyone is giving me the thumbs up. Very good, very good.
So we have a doubt regarding previous class. Ma'am, in the last class I asked a question about the balloon part, where you showed us the balloon which had air is more heavy, but when we throw is from up the balloon, which don't have sir in it fall faster. So how come the balloon which have air is heavy?
It is not like that. It is a gravitation, right? It is not like that. It is purely the gravitation. If we throw the balloon, it comes slower. It is gravitation, purely the gravitation. So, yeah, it explains by the gravitational force. Yes, that's it, right? Everyone understood everything. What is the particles of matter? Come. That is the next point. Here we go. The particles will be having intermolecular space between them. Intermolecular space. Let's play the animation here. So when we add sugar particles, the sugar particles will get into the space of these particles. Okay, I have told you the particles will be having intermolecular space, and the sugar particles over here can get into the space of that intermolecular space over there. That is why the level of water was not increasing. Now it makes sense, right? Definitely yes, ma'am. Okay, let's move forward. Yes, sir, you can remove it. The next point was the particles of matter are continuously moving. That was the second characteristic. Particles of matter are continuously moving is the second characteristic. Okay, we had discussed that. Now, by doing an experiment, we have proved this, right? Yes, by pouring ink into the water, we have proved that ink is moving down. So the particles are definitely moving. And what about the incense stick? So you can play the animation. What about the incense stick? Incense stick. If we just ignite the incense stick into the corner of the room, we'll get the smell from far away. So the incense stick will give out the Smell. We can feel that smell. We can smell it, right? Just because the particles are moving around, that's why we are getting the smell from far away. So we have explained this in the last class. So the second point makes clear that the particles of matter are continuously moving around. They are continuously moving. That was the second point. Now, you can remove it. Now, the thing is, you have to remember it, okay? The thing that you have to remember is, whenever something is moving, okay, if I have to move around like this, I have to use some energy. Am I right? If I want to move around like this, I have to use the energy. If I want to move this pen from here to here, I have to use some energy. Am I right? Am I right or wrong? If you want to run or if you want to jump from one building to another, you just have to use the energy. Like she said, she was cycling. So in order to cycle, we have to get some energy. Likewise, our particles are also moving, as I have told you. So can we have the animation of water again? I have told you the particles of matter are continuously moving. If they want to move around, yes, if they want to move around like this, if they want to move around like this, they want to get some energy. They want some energy in order to move like this. The particles of matter are continuously moving. In order to continuously move like this, they want a specific kind of energy. Without energy, how can they move around? Tell me, how can they move around without any energy? So they definitely needs one energy. You can remove it. They definitely require some energy. Can you tell me what kind of energy will that be? What kind of energy will be it?
Let's unmute someone. Okay, let's unmute.
I haven't taught that yet, but everyone knows that, I guess.
Okay, Meher.
Meher. Yes, Meher, can you tell me what kind of energy is required to move around? Not just the particles, for us also. What is the energy that helps us to move around?
Actually, don't know. Static.
No. Not only in the case of particles, it has been studied that in the physics, I guess. In order to move around, we want some specific kind of energy. We have the answers in the comment box.
Yes.
Very good. Very good. Now let's unmute someone from the hand raise.
Okay, let's unmute Sriman.
Sriman. Yes, Sriman. Sriman?
Yes, ma'am.
What kind of energy is that?
Kinetic energy.
Kinetic energy. Very good. Kinetic energy. We have the kinetic energy. So meteors walking, falling, and the aeroplane and throwing the ball all needs some energy. Okay, we want that kind of energy, and it is called as the kinetic energy. So what is kinetic energy? Kinetic energy is the energy an object has due to motion. So in order to move, we want a certain kind of energy, and I can call that energy as the kinetic energy. Kinetic energy is the energy of an object due to motion. Okay, in order to move, we want, or the object wants, some energy, and that energy is called as the kinetic energy. Kinetic energy. Likewise, in order to move or in order to fall or meteors, they are all moving, right? In order to move, we want the energy, and that energy is called as the kinetic energy. Is kinetic energy clear for you? We will study detailedly about the kinetic energy in physics, okay? So just remember, in order to move, we want the kinetic energy. In order to move, we want the kinetic energy. Just remember that, okay? Kinetic energy, we want the kinetic energy. So don't ever forget the term kinetic energy. So likewise, I have told you the particles inside the matter are moving around. The particles are moving. So they also must contain this energy, right? Am I right? The particles should also have this kinetic energy, then only they can move around. So the particles of matter will be also having the kinetic energy. So don't ever forget the term kinetic energy. So whenever you talk about the characteristics of particles of matter, you have to mention the kinetic energy. Okay? Yes, sir. No. It was an image. Okay. Now the thing that we have to remember. How does it affect? Okay. How does it affected by other factors? How does the kinetic energy affected by other factors? Are you all following me? Are you all following me? Writing down everything? Are you writing down everything? Neha can't do it, of course. Yeah. Except Neha, rest of you are writing down, right? Very good, very good. So you have to follow me, okay? I want your 100% attention during the class. So pay attention. Here we go. The particles will be having kinetic energy. And this kinetic energy is directly proportional to temperature. Write it down. Quickly write it down. The kinetic energy is directly proportional to what? To temperature. Write it down first and I'll explain it. Okay, the kinetic energy is directly proportional to temperature. As the temperature increases, kinetic energy also increases. Okay, as the temperature increases, kinetic energy also increases. Always remember that. As the temperature increases, kinetic energy increases. Kinetic energy is directly proportional to temperature. Yes, sir, the animation. Yes, here we go. Yes. Here we go. Can you see? The particles are moving around so slowly. They are moving around. I hope you can see that. The particles are moving around. Now, I have provided some heat. Now, I am heating this. So, the particles are moving faster than before. That is, they got more kinetic energy to move around. So the particles move faster when the temperature increases. That means they are getting more kinetic energy by increasing the temperature. That is why I have told you the kinetic energy is directly proportional to temperature. As the temperature increases, kinetic energy of the particles increases. As the kinetic energy of the particle increases, they can move faster. They move faster. Is this point clear for you? Before, the particles was moving very slowly. Then I raised the temperature. Then I burned the jar and the particles inside the jar got more kinetic energy so that they moved so fastly. Was the point clear for you? Is that clear? Give me a thumbs up. Give me a thumbs up. We have the hand raised, ma'am.
Okay, let's ask Abhineet.
Abhineet. Yes, Abhineet.
Ma'am, like you said, kinetic energy is directly proportional to temperature. So does that mean our bodies are more active in summer seasons than in winter seasons?
I didn't get the question. Can you repeat it again?
Now, like you said, kinetic energy is directly proportional to temperature.
Yes.
So does that mean our bodies would be more active during summertime than winter time?
No, it is not like that. I'm talking about individual particles over here, okay?
Okay.
It's not like our human body. I'm talking about the individual particles. They can move around so fastly. Not talking about ourselves, okay? So when in the summer days I'm getting more temperature so that I move so fastly. It's not like that. I'm talking about individual particles over here. Okay. Yes, the particles will be having the kinetic energy. They will move around so fastly if the temperature is higher. Okay, you can remove that, sir. So the kinetic energy when temperature increases, kinetic energy of the particle.
Actually, ma'am, can you explain the definition of kinetic energy again?
Yes, kinetic energy of the particle increases so that they move faster.
And also we have a request to summarize everything that you will study today.
Yes, I will. At the end of the session, I will summarize everything. Here we go. When the temperature increases, kinetic energy of the particle increases. First of all, what is kinetic energy? Kinetic energy is nothing but is the energy of an object has due to the motion. So if we want to move around, we want certain kind of energy that is called as the kinetic energy. So every particle of matter are moving around. They have the ability to move. So they must possess some kinetic energy in order to move. In order to move, they must possess some kinetic energy. And that kinetic energy is directly proportional to temperature. Kinetic energy is directly proportional to temperature. Okay, so if the temperature increases, kinetic energy of the particle also increases. If the kinetic energy of the particle increases, they can move so fastly. So the thing that you have to remember is the particles of matter are in continuous motion. The particles of matter are in continuous motion and they possess the kinetic energy, and the kinetic energy is directly proportional to temperature. Was the point clear for you?
Okay,
Anyone have any doubt?
Yes, Mohammed Sohail.
Muhammad. Yes, Muhammad.
Yes, you said kinetic energy increases, right? When
Yes.
the temperature increases.
Definitely.
What about hot air balloon?
Hot air balloon. Yeah, that's why they are moving around, right? Yeah, we are
Yes.
providing the heat energy. That is why they are moving around. So without that heat energy over there, the balloon will not go away, right? With the wind, they want some energy to move. So that's why we are providing the heat energy.
Okay.
Yes. Do anyone have any other doubt?
I think one more doubt we have. Explain the directly proportion temperature again.
Yeah, definitely. So I have told you. What who was that?
Sanjita.
Can you please unmute here?
Okay.
Yes, Sanchita.
Oh, wait,
Yes.
Yes, Sanjita.
Sanchita,
Yes, ma'am.
did you understand what is kinetic energy?
Yes, ma'am. I understood
Yes.
that one.
Now, kinetic energy is directly proportional to temperature. Okay. So that means if I increase the temperature, okay, if I increase the temperature, temperature increases, okay. If I raise the temperature, kinetic energy of the particles will also increases, okay. If the temperature increases, kinetic energy of the particles also increases. As we seen in the animation, before the particles was moving very slowly, then I raised the temperature so that they got more kinetic energy. If they get more kinetic energy, they can move around so fastly. That means the kinetic energy is directly proportional to temperature. If one increases, other one also increases. If temperature increases, kinetic energy also increases. It is directly proportional to one another. Okay, if one constant is increasing, another one will also increase. Okay, as the temperature increases, kinetic energy also increases. If kinetic energy increases, they move faster. They move faster. Who will move faster? The particles will move faster. Is that clear? Is that clear, Sanchita? Very good. Very good. So this is about the second characteristic. Is that clear? Is the second characteristic clear for everyone? Give me a thumbs up. A double thumbs up.
Yes.
A double thumbs up. Yes, very good. Very good. Very good.
Ma'am, if the temperature decreases, does the kinetic energy decrease?
Definitely yes. As the temperature decreases, kinetic energy of the particle will also decreases. Okay, let me give another example of the copper sulfate. So let's have the animation. Let's look into an animation. Okay, we want the experimental proof for everything, right? Here we go. Yes, sir. Here we go. We have two beakers. One is filled with the hot water and the second one will be filled with the cold water. Which one will be having more temperature? Which one will be having more temperature? The hot water or the cold water? Comment it. Comment it. Which one will be having the more temperature? Hot water or cold water? Everyone is going with the hot water. Now let's unmute someone.
Okay, let's ask Abid.
Abid.
Yes, Abid.
Abid. Abid?
Yes.
Yes. What happens to the kinetic energy if the temperature is high?
The particles move faster.
Particles will move faster since they possess more kinetic energy in the high temperature. So, if I add this is copper sulfate, okay? The blue color crystals are nothing but copper sulfate, okay? Copper sulfate is blue in color. So, what do you think if I add this copper sulfate in both the beaker at the same time? Which one will dissolve faster? What do you think?
The hot water.
In the hot water. Why? Why? Can you explain why?
Because in hot water the particles move faster, so the copper sulfate powder can get its place in the water.
That's very good, very good. Now let's play the animation, sir. Here we go. Here we have the copper sulfate crystals. Okay, copper sulfate crystals. And let's take copper sulfate in both the beaker at the same time. What is your observation over here? What is the observation? The first one, the hot water got color fast. That means the copper sulfate dissolved in hot water quickly and faster. Just because the hot water will be having higher temperature than the cold water. Hot water will be having higher temperature. That is why the crystals are dissolving faster in the hot water. As the temperature increases, kinetic energy of the particle increases. They move fastly. If they move fastly, they dissolve faster. They dissolve faster if they move around so fastly. So the thing is, as the temperature increases, kinetic energy of the particle increases. Let's unmute someone, ma'am.
Okay, we have one more Abid. Let's unmute him.
Yes. What is the name?
Yes, Abid.
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 Yes,
Abid. So what did you understood from this experiment?
Ma'am, I understood that the higher the temperature, there is more kinetic energy.
Yes, definitely. Very good. As the temperature increases, kinetic energy of the particle increases so that it dissolves faster. So have you ever experienced when you added sugar to water? It was dissolving, and when you heated that particle or the water, they got dissolved faster. While you're making tea, have you ever experienced that? Have you ever experienced that?
No, ma'am.
No. So, will you make tea or coffee in your home?
No, I do not make.
That's fine. Okay. Do anyone have the experience in our class?
Yes.
Yes, the girls are like, yes, ma'am, I always make the tea in our home. So I have that experience. So in a glass of water, if you add sugar, it is not dissolving so faster. So if you just heat that glass, the sugar particles will heat faster, will dissolve faster. That means as the temperature increases, kinetic energy of the particle increases, they move around fastly, they dissolve faster. So that's the point that I am making over here. Done? Clear? Everything clear?
Yes.
Is everything clear?
We
Now,
have one hand raised. Eric.
Eric, yes, Eric.
Ma'am, so with this experiment, what I was about to ask,
Yes.
we understand that in hot water, everything dissolves faster,
Yes.
and in cold water,
Yes.
it dissolves much slower.
Yes.
So is that why, like when we make, let's say for example, cold coffee, we use a blender?
Definitely,
So
yes.
when the blades move, it produces more kinetic energy, which then in result increases the amount of movement of each particle,
Definitely.
making.
Definitely. So they will not be having enough kinetic energy. So we are providing an external energy for them. Okay, we are providing external energy so that they mix faster.
Okay.
Definitely. Now I have a question. Someone is.
And also, yes, we have
Who's
yes,
that?
Daniel.
Daniel. Let's get Daniel.
So teacher, if hot water increases in the teacher. So if we put anything different in oh yes. So if we take something like oil and put it in hot water and cold water, what will happen, teacher?
So the thing is, they have different densities. Okay, it completely depends on the density. Okay, so the particle, the oil and the water, they are inorganic and organic compound. They are polar and non-polar. You will study that later. Okay, so I'm not going to confuse you with that because you don't have to study that right now because there are so many things going around behind that. Okay, so oil and water, we'll study that later.
Okay. One more. John.
Yes, John.
Ma'am, if there was any molecule that could absorb the heat, then will the kinetic energy last even though if there's less temperature in its surrounding?
I didn't get that. Can you repeat it again?
So if there was any molecule that could absorb the heat, if the surrounding would have a low temperature, would the kinetic energy still continue?
No, it's not like that. So surroundings will also matters. Okay, it also matters. That's the thing that we are going to study. The next portion is that one. The factors which are affecting the movement of the particles. We'll study that. Okay. In the coming topics, we have that particular topic. We'll learn the.
Okay.
The surroundings will also a major factor. Definitely yes. So now I have a question for you. Okay, I have a question. I have a hot noodle soup. Okay, and in other hand I have a cold something cold cake. Okay, let me a cake. So I have a cold cake and hot soup noodles. Okay, hot chicken noodle soup or anything. Okay, so which one will get a faster smell? Okay, can you smell the cake faster or the chicken noodle soup? Hot chicken noodle soup or the cold cake? Which smell will you get faster?
They are
You
saying
can
the
remove the
noodles
animations,
first,
sir.
I think. Yeah,
You
everyone
can
is
remove the
going with
animations.
salute.
Is that the cake? Remove it. Is that the cake? No, ma'am. It is hot chicken noodle soup. So why? Why are you getting the smell of hot chicken noodle soup rather than the cold cake or cold chicken noodle soup? Okay, let be the same. Okay, hot chicken noodle soup and the cold chicken noodle soup. Which one will smell faster?
Okay, let's ask Hannah.
Hannah. Yes, Hannah.
We have a lot of hand raised.
Because the particles in that soup will it moves faster, so we can get the smell easily.
Yes, that's it. Very good. So while we cook or while we do something, the hot ones will be having the aroma. The particles inside the aroma will be having higher kinetic energy since they have higher temperature. So they move faster than the cold one which will be having a lower temperature. So which one will move faster? The hot one will be having high temperature and high kinetic energy so that they move faster than the cold things. So always the freshly prepared, the hot ones will be having higher smell than the cold ones because the particles of that aroma of that food will move faster, because they possess higher temperature and higher kinetic energy. So in the exam, if they ask like if you have a cold food and the hot food, which smell do you get faster? You have to answer it like the hot one will give out the smell faster. Okay. Was the second point clear for you? Let's unmute someone, man.
Okay, let's unmute Vinayak.
Yes, Vinayak.
Yes, ma'am.
Was everything clear?
Yes, ma'am.
What was the second point? Second
Ma'am,
characteristic.
What, ma'am?
What was the second characteristics of particles of matter?
Ma'am, that second characteristics is that the particles can attract.
Attract?
No, no. Well, the first one is a space,
Ah.
and then the second one, ma'am, the second one is continue. Ma'am, I think it's moving.
It's moving. Who is moving? Me?
Ma'am, the particles are moving.
The particles are moving. The particles inside what?
Inside the object.
Object of the matter. Very good. So the particles of the matter are in continuous movement or motion. That was the second characteristic. Now let's move towards the third one. Okay. Particles of matter attract each other. The particles of matter attract each other. Is that right? Are they attracting each other? Are they attracting each other? So the thing that you have to do is, don't do it right now, okay? When you go to take the bath or in your bathroom, do it, okay? Not in your rooms. Don't ever do that. Your moms will come and kick you out from the house. So don't do that. Now, if you are taking a bath, you have to check it, okay? So you have to throw some water like this, okay? You have to throw some water like this. And you have to notice what happens to that water molecules, okay? And you have to let me know in the next session. You're going to let me know in the next session, okay? You have to throw the water, okay? In the air, you have to throw the water, and don't do that in your rooms or hall. Don't ever do that. So you have to throw the water, and you have to let me know the observation, okay? In the next class, I will ask that. Now, the particles of matter attracts each other. Is that true? Let's take out one paper, okay? Let's take out one paper. Let's take out one paper, okay? So why are they have the specific shape? Why do they have the specific shape? Because the particles inside this matter are attracting each other. And let's tear it, okay? Let's tear the paper. You can tear the paper, right? Yes, I can tear the paper. And it was like I had to apply some pressure in order to tear. Am I right? I had to. You can check it. I had to apply some pressure in order to tear it. I cannot tear with the simple looking. Can I do that? Can anyone do like, let it tear. Can anyone do that? Someone is like, yes ma'am, I can do that. Do you have that superpower? Who else have that superpower? By just looking, tear it. Definitely I don't have that. I just had to apply some pressure in order to, or apply some force in order to tear it. In order to tear, I had to apply some pressure. That is explained that the particles of matter attracts each other. If they are not attracting each other, they just fall away, right? So if they are not falling away, they will be having a specific shape. That means the particles inside this will be having the specific force of attraction. Okay, the particles of matter attracts each other. So it will be in different amount, okay? The force of attraction between the particles will be different in different objects, okay? I can tear this paper because the force of attraction of these particles will be weaker. So can I break this pen? Can I tear this pen by just applying that kind of pressure? I cannot do that. I cannot do that. Why? The force of attraction inside this particle will be stronger than the paper. Than the just paper, the force of attraction inside this pen is more. Likewise, I can just hold my hand like this. Okay, everyone, hold it. Hold your hands like this. Everyone, hold your hands like this. Okay. Okay, now just try to separate it. Now just try to separate it. Okay. You are applying some force, right? In order to just break them, you are applying some pressure. Okay, now hold it like this. Hold it like this. Now it was much easier to break it, right? It was much easier than before. Now just hold it like this. It is even more simpler to remove it. Am I right? You can just try it again. This was easy, this one or this one? Which one was the easiest one? Comment it. The first one, or the second one, or the third one. Which one was the easiest? Easiest. The third one. All of this. All of them was easy. I'm just telling you to compare compare it, okay? Compare the force that you're applying over here. Compare the pressure that you have to apply for breaking this, okay? So this was easier. That is why I have told you the force of attraction between the particles is different in different objects. Like the first method, the second one, and the third one. So they will be having different kinds of force of attraction between different objects, okay? So in order to break this pen, I have to apply more force. Can I break my any stone by using my hand like this? No, my hand will get broken, right? Like Neha's hand, my hand will be broken if I hit the stone like this. I cannot do that. So everything will be having their own force of attraction. The force of attraction will be more in some kind of objects and it will be less in some kind of object. Okay, so that explains the particles of matter attracts each other. They attract each other. Now, what is this force of attraction called as? Definitely, they will be having intermolecular space between them. Intermolecular space. Now, what does the force? What will be the force? Just imagine what will be the force. If they have intermolecular space, what is the force between the two particles called as?
Okay, let's ask.
Yes, we have the answer in the comment box. So very good, very good. It is intermolecular force of attraction between the particles. Okay, the force of attraction between the two particles is known as intermolecular force of attraction. Intermolecular force of attraction. Okay, the particles will be having intermolecular space between them and two particles will be having intermolecular force of attraction between them. Some of them will be having weak intermolecular force of attraction and some will be having a strong intermolecular force of attraction. Okay, was that clear? We have the hand raised, man.
Okay, let's ask Sriman.
Sriman.
Ma'am, we take two books and interlap with each other, the pages. So it's an example?
Definitely yes, it is an example.
Okay, ma'am.
So if we want to separate them, we have to apply the pressure. We have to apply the pressure in order to separate them. We have to apply some force in order to break them. So the particles of matter attracts each other. And again, I have told you, you have to throw the water in the air and you have to let me know what is exactly happening over there.
Okay.
Yes, that's it. Done?
Daniel.
And Daniel again. Yes, Daniel.
So, teacher, this one I don't think this is not any force, but like when you bath in like really hot water, the fog will come out, right?
Yes.
The fog.
Yes,
So
definitely.
if you have a mirror, like a little bit far, but a little bit close to you, and if you bath in that hot water, for after some time the mirror get fogged up. So is that an particle attraction?
No.
Mirror?
It is another thing. The water is in liquid state and it will turn into gaseous state and again it will condense in the mirror. I'll explain that, okay? If I just explain like this, you will not get an idea, but with the examples, with the animation and the PPT, you will get a better idea, okay? We have those topics in our chapter. Don't worry. Okay. So, is this 3 points clear for you? 3 characteristics of particles of matter clear for you? The first one was the particles will be having space between them and the particles of matter are in continuous motion and the particles of matter are attracting each other. These are the 3 characteristics of particles of matter. Simple, right? That was simple. Am I right? Is there any difficulties in studying these 3 characteristics? No. Everything was so clear so far. Very good. Very good. Now let's move forward. Okay, let's move forward. We have to specifically study the 3 states of matter. So the animation. We have to study the 3 states of matter so deeply. Okay, we have to study it. Let's check it. How to study these 3 states of matter. Yes. What are the 3 states of matter first of all? The first one is nothing but solid, and the second one is what? The second one is nothing but a liquid, and here we go, the liquid. And the third one is nothing but the gas. Okay, we have three states of matter. Which are those? Which are the three states of matter? Solid, liquid, and gas. We have three states of matter: solid, liquid, and gas. Solid, liquid, and gas are the three states of matter. Ma'am, what do you call the force of attraction between the molecules? Intermolecular force of attraction. Okay, intermolecular force of attraction. Ma'am, one doubt. Who is there?
Yes.
In the comment box.
Okay. Mehrab.
Mehrab. Yes, Mehrab.
Ma'am, can you go to the previous slide, like states of before that?
Wait a second. Here. Okay. Fine.
Yes, ma'am, this one.
This one?
Can you hear me?
Yes, I can. There was a lot of noise pollution over there.
Ma'am, in the first, you're saying that they have space between them, but then you said they attract each other.
That is why I have to told you to do the experiment, right? You had to throw the water and let me know what is happening over there in the first class.
I always do that in water. I throw the water up.
You throw the water already?
Yeah, I always do that.
Yeah, you have to do that, and you have to let me know what is happening over there in the next session, okay?
Or it first gets separate and then it joins down.
What it explains.
Well, like they can have space, but then they attract each other.
That's it. They attract each other. That is why they are getting separated and joined together again. Because they are attracting each other.
Okay, ma'am. I got the point. I understand.
Okay, still you have to do it, okay? Yes. Who's that, ma'am? Here. Below.
Okay.
We have so many hand raises.
Yes.
Let's unmute one by one.
Niranjan.
Niranjan, what was that, Niranjan?
Yes, ma'am. I do the same thing as Mehrab did. Ma'am, but what I see is, ma'am, it depends on the way we throw it, right?
The way you throw, how did you throw then?
Ma'am, sometimes I throw it with pressure, but like if it's the same table, if we use the same way I did it, sometimes it gets split up or it goes in a straight line together and come down.
I just told you to take a little amount of water in your hand and just throw it like this, okay? I have shown that, right? It's not like take a bucket of water and throw it like this. It was not like that. So just take a little amount of water in your hand and just throw it like this, okay? And then let me know what is happening in the next session. Yes.
And also, yes, Sanjit.
Sanchit, yes, Sanchit.
I have a doubt, ma'am.
Yes.
Now there are two more states, ma'am, like plasma and boost.
What was that? Plasma and Bose sustain. Yes. You don't have to study that in detail, but still, I will explain what is that, okay? At the end of the session, we'll just give an idea what is plasma and Bose-Einstein condensate, but you don't have to study detailing in the syllabus, okay? Still, I will explain that.
And also Rishikesh.
Yes, Rishikesh.
Ma'am, Mehrab told, yeah, and he was looking the brush.
He was looking what?
Brush.
Brush? I didn't get that, Rishikesh.
I saw this in video, yeah. It's just blue brush.
I'm not getting what you're talking about. Which video and which brush? Did I show you any brush out there in the video? No, right?
No.
You can comment it, okay? Anyway, I'm not getting what you're talking about, Rishikesh. Comment it, okay?
Abhineet.
Did you got it? What is he's talking about, ma'am?
No.
No, Rishikesh, just comment it, okay? Just comment it. What was that?
Abhineet. Yes, Abhineet.
Yes.
Ma'am, I have noticed this before. Sometimes when I take like ice to drink cold water, and sometimes the ice get attached. Or like if I put two separate ice cubes in a glass, and after like a few seconds, 10 seconds, 15 seconds, so these ice attach with each other. So does
Yes.
that mean that when matter is when the matter is cold, the what do you say, the interparticles
Force of attraction will be more.
Yeah.
Yes. That I will explain this in the specific topics. Okay. The intermolecular force of attraction is more in solid than the liquid than the gas. I will explain it. No worries. Here we go. Let's look into the first one, solid. Okay, solid state. Let's have a detailed view about the solid. Okay, solid. Have you took down this everything? Took down everything? Very good. The first one is solid. We have the money and the piggy bank and the solid word, books, ice cube, everything is solid. So if you want to save that money, just put it inside this piggy bank. Okay, always save the money. Don't waste it. Okay, so here we go, the piggy bank and the ice cube, and here you can add on more example for the solids. Okay, you can add more points to the solids. What are the solids that you can see around yourself? Come in it. What are the solids that you can see around yourself? We have laptop and me, definitely. Book, mouse and pencil, phone. Yes, we have so many kinds of solid. Okay, you know how to differentiate between a solid, liquid and a gas. I hope you know that. You are in 9th grade, so you must be knowing to differentiate between solid thing, liquid and a gas. You know that. So we have so many kinds of solid around us. Now all the thing that we have to study is the characteristics of particles of solid. Okay, generally we have spoke that what are the characteristics of particles of matter. Now we have to specifically study the characteristics of particles of the solid. Are you ready for that? Are you ready for that? Oh, very good, very good. Now let's have a look into that. The characteristics of solid. The characteristics of solid. Can you tell me what will be the characteristics of solid? Can you have a guess? Let me know in the comment section. Let me know in the comment section what are the characteristics of the solids. The visible characteristics, okay? The visible characteristics. The visible characteristics of solid.
They are hard in nature.
They have no space to
molecules
move.
are tightly packed.
They all know everything, right?
Yes.
Why am I teaching over here? They already know everything.
Strong, hard.
Strong, hard.
Soft touch.
Yes. Here we go with the first point. They are rigid. They are rigid. What do you mean by rigid? What do you mean by rigid? That's the first characteristic of solid. They are rigid. What do you mean by rigid? Ma'am?
Oh,
Unmute.
yes. We are gonna mute Aryan.
Aryan, yes.
Yes, Aryan.
This is the general characteristic, okay? But we have the exceptional cases. Don't worry about them. Just we have to learn the general things. What do you mean by rigid? How can the solid be rigid? Yes.
Aryan, will you please unmute?
Aryan. Hello. It's not able to, I guess. So rigid means they are strong and they are hard. The solid will be hard and rigid. They are very strong and they have a hard nature, like the pen. The pen is rigid. I cannot break it. They are so rigid. Okay. They are very hard. They are very hard and strong. That means they are rigid. Okay. That is the first point that you are going to make. They are rigid. Okay. They are rigid. Now, the second point, they have a fixed shape. They have a fixed shape. I have the pen. The pen will be having a fixed shape. So if I come back tomorrow again, the pen will not change its shape. It will not change its shape, right? They have a fixed shape. They have a fixed shape. shape. I have the phone right here, and the phone will be also having a fixed shape. Day after day, it will not get smaller and smaller again. It will not do that. It have a fixed shape. And me, I have a fixed shape. I will not change. I will not become a circle by tomorrow. I cannot do that, right? So the solids will be having a fixed shape. Okay, you have to remember that. They are rigid. They have fixed shape. That is the second point. Now the third point. They have fixed mass and fixed volume. They have fixed mass and fixed volume. The pen will be having a fixed mass and fixed volume. Volume is the space that they are occupying. Volume is what? The space that they are occupying is known as the volume. Okay, volume. So, you know what is mass and volume, right? Mass is the weight and volume, the space occupied by the substance, is called as the volume. Okay, everything will be having their own volume. Was that clear? Was that 3 points clear for you? Is it the 3 point clear for you?
John has a doubt. I think.
Yes.
Yes, John.
Now I have one question.
Yes.
Animals that go through metamorphosis, what about them? They have fixed shape in the beginning, but then they change after.
What was the example?
Animals that go through metamorphosis, that change their body, like frogs or butterflies.
Yeah, we also changes the shape from the beginning, that is called as a growth. Okay, that doesn't explain this. Okay, that's a growth. That is a different thing. So we all grow, right?
Yes.
That's the state of growth.
Okay.
Yes. So talking about specific things like a phone or the pen or table, chair, they will be always having the fixed shape and fixed mass and fixed volume, and they will be rigid, they are strong, they are hard. Those are the characteristics of solid. Okay. And
What
do anyone have
about
any doubt?
Sponge? Yes, Daniel. wants to say
Yes,
something.
Daniel.
So, teacher, like you said, that solid shapes are fixed shape, right?
They have a fixed shape, definitely.
So, teacher, what about ice? You said ice is liquid.
That is the change of state of matter. The ice can be converted into water by applying some temperature. Okay, that is change of state of matter. I'll explain that. Everything is like, I'll explain later because these topics are coming in the next sessions. Okay, everything you have to study everything. That is coming in the next sessions. Okay, that is the change of state of matter. I'm talking about a specific state right now, not changing it. Okay, specific state, solid state. Ice, talking about the ice will be having a rigid structure. They have a fixed shape, fixed mass and fixed volume. Okay, when they change into liquid, they have the properties of a liquid.
Okay, teacher. Because teacher, you said that today the shape will be like this, like, and tomorrow it won't change. Like if you see ice, like if you see like ice, teacher, the ice would have today the ice will be normal shape, but the next day it will turn like it turns smaller. That's why.
It is changing its state, right? By decreasing the temperature, it is changing. By increasing the temperature, it is changing its shape. So when you have the ice block in the refrigerator, for tomorrow also it will be having that same shape. Am I right? At the fixed temperature, at the fixed constant rate, they will be having that fixed shape. Am I right? If you take that out and keep it over there, definitely it will melt because the temperature is changing. They're changing the state of matter. So if you keep at the same temperature, they'll be having the same fixed shape. Okay?
Okay.
Is that clear?
Yes, teacher.
Yes, very good. Here we go with the animation. So the animation. Is the 3 points clear? They are rigid, they have fixed shape, they have definite mass and volume. They will not change their shape. Let's look into the animation. And the next point, they are incompressible. Wait for a second, say. They are incompressible. I forgot to tell that. They are incompressible. What do you mean by incompressible? Talking about this pen, I'm trying to compress it. Can I do that? Can I compress this pen again? Pen is solid. Can I compress this pen? No, I cannot compress this pen, right? Because this pen is already in the compressed state. So if I apply more pressure for compressing this, it will break. It will just break. It cannot be compressed in another form. So we cannot compress this solids. They are incompressible.
Actually,
They are
they're asking about sponge, spring, etc.
yes,
Then
coming.
okay.
Wait for our students are not patient enough, right? They have to know everything right now. So we have to learn step by step, right? Everything is coming. Here we go. They are incompressible. They are incompressible. Rigid, fixed shape, fixed mass and volume. They are incompressible. Here we go with the animation. Yes, sir. So are they changing in shape? Let's take down. I have the glass over here. If I pour water, the water will be having the shape of that glass. Am I right? The water will occupy everywhere. But talking about the solid, let's take it down. If I put one what is that? Ball over there in the glass, it is not changing its shape. It occupies the same size and same volume as it is. Okay, it is not occupying any other extra space over there. It is same as such. It is not changing its shape. It is not occupying any other extra space over there. It is just the same. Okay, that means they have a fixed shape, they have a fixed volume, they have a fixed mass, and they will not change the shape. Okay, they will not change the shape. Now you can remove it. Let's take the example of this Rubik's Cube. I have the Rubik's Cube over here. So how many of you know to solve this Rubik's Cube? Yes, who is that? The first one ma'am over there.
Okay, there's John.
John also had the
Yes.
Rubik's Cube. He is showing me the Rubik's Cube. Ma'am, I also have the Rubik's Cube with me.
Yes, he has 4 into 4 type.
4 into 4.
Yes.
I have the 3 into 3.
Yes.
So how many of you know to solve this Rubik's Cube? Raise your hand. Just raise the hand.
John, no. Niranjan, no.
Many knows.
Yes,
Many
Many
knows.
of them know.
Many knows how to
Fatima,
solve
yes.
this.
Abed, Ayman, Aryan,
Very good.
everyone.
Very good, very good. So Ayman have the Rubik's Cube in his hand and one there. Everyone is holding the Rubik's Cube. Very good. If you have the Rubik's Cube with you, you can just hold it and check it, okay? Yes, very good. Have the Rubik's Cube. And let's imagine this is a solid. Not just imagine, this is definitely a solid. Definitely it's a solid. You don't have to imagine that. It is definitely a solid. So here we have the solid. As you can see, this solid will be having a fixed shape. Am I right? This will be having a fixed shape, fixed volume, and what else? Fixed mass. Definitely they will be having a fixed mass. And compress it. Compress it. Can you do that? Can you compress it? Never, because they are incompressible. They are incompressible. Now we have talked about the external features of the solid. Okay, external features of the solid. Now what about the inner particles? What about the particles of the solid? Okay, particles of solid. What about the characteristics of particles of solid? Imagine these cubes inside this Rubik's Cube. Okay, imagine, everyone listen carefully. We have so many cubes over here, right? Small cubes which repeatedly join together to give you a large cube. Okay, we have small cubes in it. Imagine these small cubes are the particles of matter. Okay, you have to just imagine. Okay, the particles are very small. You cannot see them. Just imagine these are the particles of matter. You just have to imagine this. Okay, these small blocks are the particles of matter. Just imagine. Now we have to check the nature of the particles. Here we go. The first one, they most closely packed. As you can see, the particles are closely packed. The small cubes over here are closely packed, as you can see. Can you see that? The particles of matter are closely packed as this Rubik's Cube. Okay, as this Rubik's Cube, the particles, each cube is closely packed. That's the first characteristic of particles of solid. Okay, the first one is they are closely packed. Can you see that? Every cubes are closely packed with each other. They are closely packed. So whenever you think about a solid, just think about this Rubik's cube. The particles each cube are closely packed. They are closely packed. And can you see the space in between them? Can you see the space over there? Can you see the space in between those particles? Definitely you can see small space over there, and that is why they are almost negligible, but we can see the space. Okay, the space will be there, but it is almost negligible. The space between the particles is almost negligible. As you can see in this cubes, the space over here, they are very small. They are very small. They are very small. That means they have a negligible small space between the particles. And if I just try to separate these particles, okay, I'm just trying to separate this particle. Okay, if you have the Rubik's cube, take it and separate the particles. Okay, these cubes, small cubes are the particles. Now just try to separate it. Can you do that? Can you separate? Are you able to separate them? John is like, yes ma'am, I can separate them. John, can you separate these particles over here? Unmute him, ma'am.
Okay.
Ma'am, a normal cube, like the Rubik's cube, basically made up of smaller pieces, and you can actually take them out.
So they will be having a magnetic particle so that they can separate. It's not like that, okay? I'm talking about...
It's not magnetic. It's not magnetic. Yes, you can separate them.
They cannot separate it. We can just stretch them, but we cannot separate the particles. Okay, we cannot separate the particles because the force of attraction.
Please, actually.
Someone broke them. Don't break it. Just
it's
try.
Fixable, man. It's fixable.
It is fixable. I know it's fixable, but I'm not telling to break them. Just try to separate them like this. Okay, don't just. I got this. It's not like that. Okay, don't do that. They are breaking the cubes in order to prove me wrong. So it's not like that, just humbly and gently, okay? So this force of attraction between the particles is very much stronger. So you have to apply more pressure or more force in order to break them. In order to break them, you have to apply more force, right? So the force of attraction between the particles are very strong. They are very strong. So whenever you think about the solid, just imagine the Rubik's cube and the particles. The particles will be having a strong force of attraction. They are closely packed and the space between the particles are negligible, almost negligible. These are the characteristics of matter of solid. Okay, solid. Was that clear for you? Was it clear for you? Here we have the particles. Imagine these are the particles. Okay, these are the particles of matter. Imagine, you cannot see them anyway. Imagine these are the particles of matter. As you can see, they are closely packed with each other. In solid, they are closely packed with each other. And if you want to separate them, we have to apply more pressure. That means they will be having a strong intermolecular force of attraction. Intermolecular force of attraction between the particles very much stronger, and intermolecular spaces are very less, almost negligible. You cannot see the space over there here, right? It is almost negligible. It is almost negligible, very small space. So what do you mean by this characteristics of particles of solid? They are most closely packed. The space between intermolecular space between the particles is almost negligible, and the intermolecular force of attraction is more in the case of solid. Okay, in the case of solid. Let's have an animation. So the animation. Let's look into the animation. Yes. Here we go. An example for the solid, ice cube. Ice cube is an example for the solid. And let's look into the particles of the solid. Okay, let's look in. Yes, sir. Let's check. Here we go. What does the particles looks like in the solid? Pause there, sir. Here we go. The particles, as you can see, they are closely packed. Okay, they are closely packed. And the space, intermolecular space will be very less. And the force of attraction, intermolecular force of attraction is very high in this case. Now, my question is, if they are closely packed, if they doesn't have space in between them, if the force of attraction is very strong, will they move? Can the particles move? I have told you generally the particles are moving around. Now in the case of solid, are they moving? Are they moving? Are they moving? Are the particles moving? That is my question. Yes, sir. Unmute someone.
Okay.
Are the particles
Let's
moving?
unmute Aryan.
Aryan.
Yes, Aryan.
Aryan, is the particles moving around in solid? In the case of solid,
It's not moving.
it is not moving. Are you sure?
Yes.
Definitely, it is not moving. Let's look into that. So play the animation. Yes, see that? Did you saw that? Can you just replay that again, sir? Yes. Here we go. The particles are moving. The particles are moving. Don't ever get confused with that. The particles are moving, but not like moving around like this. It will not move around like that. But each particle will be having fixed position. Each particle will be having fixed. They will be having fixed positions. Okay, each particles will be having, you can remove that, sir. You can remove that. Yes, the particles inside the solid will be having a fixed positions, and they only vibrate. They only vibrate in that position. They vibrates in that position. Okay, they vibrates in that position. They are actually moving, but they will be having a low kinetic energy. They will be having low kinetic energy. In the case of solid, the particles will be having lower kinetic energy, and they have a fixed position. They vibrates in that position. They vibrates in that position. Okay, they will not move around like that in the liquid or in the gaseous state. They have a fixed position. They only vibrate in that fixed position just because they will be having a lower kinetic energy, and they doesn't have enough space to move around. Do they have enough space? Do you think they have enough space to move around? No, they will definitely no, they'll not be having enough space to move around. So they will be having low kinetic energy, so that they cannot move so faster. They vibrates in its position. So as you can see in that image, can you tell me the characteristics of solid and the particles? Ma'am, can you please unmute one? Yeah, it's almost time.
Yeah.
Let's teach this again. Let me conclude this,
Ruben.
and let's
Yes,
have
Ruben.
the exam. Ruben, can you conclude what is the characteristics of the particles of matter and the solid?
Can you hear me, ma'am?
Yes, I can.
Ma'am, the solid, the particles move like in a tiny, like a view. Like the solids keep on moving.
They will
Then,
not.
the solids.
The movement is very slow, and the movement is very slow. Okay, they cannot move so faster because they possess a lower kinetic energy. They cannot move like that, but they just vibrate like this. Okay, they cannot move around. That's why they have a fixed shape. If they doesn't have a fixed shape, they can move around. Since they possess a fixed shape, if they move around, the shape will collapse. So they must possess some kinetic energy so that they only vibrate in this fixed position. Okay. Now they are rigid. That's enough. They are rigid. They have a fixed volume. They have a fixed mass, and the particles will be having a low kinetic energy, low space between them. Low space between them, and the force of attraction is a very, very strong force of attraction between the particles. Was everything clear? Was everything clear for everyone? Very good, very good. What about others? Is the points clear? Is the points clear for everyone?
Yes, I think so. But we have two more hands.
Hand raises. We have hand raises. Very good.
Yes, Neha.
Neha, yes, Neha.
Ma'am, I've been raising my hand for such a long time.
I didn't saw that.
We are.
No.
I am clearing her doubts in chat box.
Yeah.
Our
It's
supporting
just
mom.
for answering also.
Yeah,
okay,
our
okay.
supporting ma'am was answering all the questions that you have asked in the comment box. Am I right?
Yeah.
Yes, you should have them mention that, right? The ma'am is struggling so much here to answer every questions in all the comment boxes. So, all right.
No, my doubt, all of my doubts are clear. It's just one last.
All right. Ask me that.
So sponge and clay is also considered as solids, right?
Yes, I had that questions here. So, the rubber band, and I have another question like the sponge. But since we don't have that much time, and I had one more question like this, since we don't have enough time to discuss that, I thought I will discuss that in the next session. Okay. Actually, I have that questions. Why the sugar is considered solid takes up the space of that glass. And the sponge, I have told you it is compressible. And how can the sponge be the solid? And rubber band, it is while stretching the rubber band, it changes its shape. So I have told you they have a fixed shape. And why are they changing shape? I had these questions and I was about to discuss that, but I don't have enough time. So I'll discuss that in the next session. Is there? Exam time, yes, definitely it is exam time. So here we go. We have to attend the exam right now because it's already time. Shall we do that?
Actually, today we are going through ERP now.
Yes.
Yes, you just clear.
So it is another mode of examination. Okay, it is another mode of examination, not like the Google form. So you have gotten information about that, I guess. So it is an ERP model question. Okay, ERP, and you will be having an external thing, right, ma'am?
What?
Ma'am, can you just explain that?
Actually, when you back from that tab now, you will get an exam kind of option. Now it will be activated. You can attend the exam there.
Okay, when you just go back, don't close. Okay,
don't leave the Zoom. You just go back.
Just,
when you the option there near the join option.
Alright, now listen to me. Don't ever turn off the camera. If you turn off your camera, it will be considered as you are absent in the class. Okay, don't ever turn off the camera while doing the examination. And the thing that you have to do right now is call your parents right now. While you attend the exam, your parents should be there with you. Am I clear? Your parents should be there with you. Now, I will give you 1 minute for that. Just call your parents, mom, father, or anyone, any of your guardians in your class or in your room. Just call them, and your parents must be there while you're attending the exam. Am I clear for everyone? Your parents must be with you. Must be with you. There is no excuse. You should not turn off the camera and you have to attend the exam. Okay? Just don't leave the Zoom.
If
You
there
can
is
just
any
go back.
problem, you just come and
Ma'am,
Yes. Who was that?
ma'am, my parents is in work, so they are not available now.
Okay. If it is like that, no worries. Okay? If
And
the parents,
when I go to the link, my camera will be off.
No, the camera will not be off. The camera will not be.
Because, ma'am, this is a tab, so it will be
No
off.
issues, no issues.
No issues.
The camera must be on.
Okay. Okay, fine. Yes. You should not turn off the camera. That is a must thing. You should not do that, okay? Never ever turn off the camera. If you turn off the camera, you will be disqualified from the examination, okay? I'm repeatedly telling that again and again. So don't ever do that. So here we have the link. Just attend it, okay? Attend it and your scores will be gone to your parents' mobile number. They will get a message, okay?
Actually, some of them are again asking for the link. There is no
link like that, okay? There is no Google form over there. Just go back from the tab and you will get a notification of the exam over there. Just click that and start the exam, okay? Don't leave the Zoom. If you have any further doubts, you can just ask in the comment box, okay? Yes. Was everything clear for you? So let me make it clear again. Yes, let me make it clear again. Just go back from the tab. Okay, go back from the tab and you will get a blue color thing over there to start the exam. The blue color, just press it over there and start the exam. Don't leave the Zoom. Okay, just go back from the tab. Don't leave it. Okay, I hope everyone is getting that.
Some of them are finished.
Some of them are finished again.
Yes.
Sarah, okay.
Finished already.
Finished.
90 plus website.
It is not in 90 plus website. Okay, just go back from the tab. It will be there, right there. Right, just the joining. At the joining time, you got the thing just below that, right? The blue thing over there. Just press there.
Actually, when you are entering the class, you will see an option for joining now.
Yes.
Below that, now you will have an option for exam. That exam option, now it will be activated. You just attend the exam there.
Yeah. Full mark. Someone got
Yes,
the full mark. Very good.
In phone also, you can attend that exam.
Yeah,
no
in phone also
no
there's
issue.
no issues. Just go back from the tab and you'll be having that thing over there. Just below the entering code, you'll be having the blue color exam.
Just go back the main page.
It will be there on the main page itself.
Some of them I didn't get still.
Still you're confused with that?
But some of them completed
They
the
are
exam.
completed already.
Some of them didn't get that still.
Yeah, if you're feeling any uncomfortable while doing the exam, you can just comment it, okay? What are the difficulties that you're facing? Just comment it. Yes, I hope it's done. Everyone has given me the marks over there. Very good, very good. You get a better idea about that. Very good.
Yes.
Shall we discuss the questions then?
Wait, Anika, yes, Anika.
Yes, Anaga. Any issues?
Ma'am, I'm not getting the exam.
You just go back from that tab.
There is no link, okay? There is no link provided over there. Just go back or minimize your Zoom. Then you will be having that over there.
Now when I went back from the tab, I only see launch meeting over there.
Okay. When you
Just do it again, okay? Do it again and check.
Again back.
Yeah.
Back.
No, it's just the link to open Zoom.us.
Can you go back again? Just one
Again,
more.
go
Press
back.
again.
You will have a tab with that join option now.
An orange and the
And
blue
white.
thing.
Orange, white, blue, that kind of tab. 90 plus.
Yes, I have a join option.
Yes,
That is
below that
just
you will get the
below
exam
that.
option.
Just below that.
Ma'am, it says today's exam, but
Ah,
it's saying that you have no schedules.
Oh no, actually I think time for
Yeah, I guess
maybe
the time.
out. Okay, maybe it is because your time is out. 10 minutes is the time.
The time, 10 minutes was the time of the examination.
Don't worry, you can correct that in next class.
Okay, no
Today
worries.
is our first this kind of exam, so just don't worry. Okay.
Since this was the first time, so no worries. Okay, since this was the first time, no worries. You can just do that again in the next session. Okay, in the upcoming session, you will get a better idea about that. So no worries. This is your first experience. So
Neha, that is the problem. Neha, no. Yes, unmute.
yes, Neha.
Even I couldn't see it before. Just reload your screen. I guess you'll get it.
You get it. Okay, just reload it as she said, and you will get it. It seems.
Okay, Mohammed Zehar.
Now we don't have enough.
No, teacher, one
time.
moment. Okay.
No.
Yes, Zehar.
Who is that?
Zehal, Mohammed
Zahal. Yes, Zahal.
Yes, ma'am.
Is that the problem with the exam?
No, I didn't.
You did
okay,
it.
you
Very
did
good.
it.
Very
Very
good.
good.
So everyone did, I guess, and let's discuss the questions right now. Okay. Okay. Let's discuss the questions. Here we have the first question. Okay. You have already answered it. Now just show me with your fingers what are the option, which option is the correct one. Okay. A form of matter has a fixed shape and fixed volume. An example of this form of matter is what?
Everyone is showing their one finger.
The first option, very good. The first option, ice is the correct one. Ice is in solid form. Very good, very good. Now here we go. The kinetic energy of the molecule is directly proportional to what? Temperature, pressure, volume or density? Definitely. We all know the answer, ma'am. It is temperature. How could you ask these silly questions to us? Yes. Here we go with the third one. The force that binds the particles of matter together is known as what? Yes, intermolecular force of attraction. Very good, very good. Here we go with the last one. Select the one that is not a matter. Not a matter. Definitely. Feeling of hot. Feeling of hot is just a feeling. It's an emotion, right? So it is not a matter. It is on the feeling that we are feeling. So it is not a matter, definitely. The one in which intermolecular force are strongest is, in order to know this, you have to know what are the states of these things. Okay. So let me clear with that. Ether is in liquid state. Hydrogen is a gas. This one is a solid. And again, this one is a gas. So which is the correct option? Definitely the third one. Third one is the correct option. The intermolecular force of attraction is stronger in the case of solids. Very good. So we have completed everything. And thank you so much for listening to me. The thing that you have to remember is you have to study everything. Okay. While you're coming into the next session, you have to study everything we have taught in this specific class. You have to study that right now after the class. Okay, after the class, right after the class, you have to study everything.
Yes, Anaga, what happened?
Anaga.
Ma'am, as Neha told, I actually,
Yes.
Reloaded it again?
Yes, ma'am. And I actually got the link and I also completed the test.
Completed the test. Very good. Very good. Now, who is that ma'am?
Yes, Sanchita.
Yes, Sanchita. Sanchita?
Yes, dear.
Yes, ma'am. I took two mistakes. One of them I got it why I got mistake. So the second one, I picked the third option, but yet I got the wrong answer for some reason.
For some reason. What was the third option? Intermolecular space, right? Intermolecular force of attraction. Third option was the correct one. I hope that was...
No, ma'am, the last question.
The last question over here. This one?
Yes, ma'am.
Definitely the third option is the correct one.
Yes, ma'am. I picked that, but I'm not sure why I got the...
Maybe you will be just by mistake.
It might be a mistake. So it was not... so for the other students, right?
Yes.
The other students got it right. Everyone got 10 out of 10. So it might be a mistake. Okay. So in the next session, you can just be more careful with that. Okay. While answering, just be more careful. You may be pressed another option. I don't know why it happened like that. So make sure to attend with full concentration. Okay. Here someone is taking photo. Just smile for him. Okay. And let's end up the session. Just smile for him. He's taking a group photo over there. Can you all smile? Cheese. Yes, someone is showing me the mug over there with the emoji. Very good. So everyone, thank you so much for your post and thank you so much for listening to me. I hope every session, every concept was so clear. And don't forget to study and come. I will explain everything in the next class also. So no worries. And you have to study everything and come to the next session. If you don't answer my questions, definitely I will give him positions. Don't ever forget that, okay? I will definitely give him positions. No excuse in that. Alright, let's end the session. And again, I'm thanking you and good night everyone. Take care and bye-bye.